All right, welcome, ladies and gentlemen, to section 2.5, combinations of functions. We're going to be looking at a couple function operations, followed up by what's called the composition of functions. So to begin with, let's look at just the arithmetic combinations. First one being addition. If I was to add two functions, f of x and g of x, I could rewrite that statement looking like this. The reason, well, let's get to the reason in a few minutes. In a second here, just let's go through the first four things here. For subtraction, I guess how I want to say this is these two things on the right, this f plus g of x, is the same statement as taking f of x plus g of x. So we're adding the two functions together, combining like terms, that sort of idea. The same thing goes with subtraction. This is f minus g of x, which is the same thing as f of x minus g of x. And that goes for our other two arithmetic combinations as well. Multiplication looks like f times g of x. Division looks like f divided by g of x. And what you're going to be getting is things that look like this. Let's say we had a function f of x is equal to 3x squared minus 6x plus 1, and I told you g of x is equal to 6x squared plus 2x plus 7. And I wanted to know what was f plus g of x. And what you need to know is this represents the sum of the two functions. So we would have 3x squared minus 6x plus 1. And we would subtract, or sorry, add, because we're adding here, 6x squared plus 2x plus 7. And in addition, we just combine our like terms. So 3x squared plus 6x squared is 9x squared. Negative 6x plus 2x is negative 4x. And 1 plus 7 is 8. So addition and subtraction is pretty simple. You need to remember that in subtraction, you need to subtract each of the pieces. So if I was to do g minus f of x, I'm going to take the function g and I'm going to say it's 6x squared plus 2x plus 7. And I'm going to subtract the entire function. Notice I'm using parentheses here of 3x squared minus 6x plus 1. And I'm going to combine like terms. So it's 6x squared minus 3x squared. So it's 3x squared. And here's what gets most people. This is positive 2x minus a negative 6x. So it becomes plus 8x. And I get 7 minus 1, which is 6. All right, so there's the addition, subtraction. Multiplication, same idea. If I did f times g, I would have to FOIL. I have to multiply the entire f of x times the entire g of x. So here would be f g of x. I would make something look like this. I would go parentheses, 3x squared minus 6x plus 1 times 6x squared plus 2x plus 7. And then I would have to distribute this 3x squared to all three pieces, the minus 6 to all three pieces, and the plus 1 to all three pieces, and combine my like terms. All right. So the arithmetic combinations are not too challenging. It's the compositions that come up here in a moment that are what's going to be a little bit more challenging. So composition is really plugging one function into another function. And here's what it looks like. This O is not actually an O, it's an operator. Just like we have f plus g, this is f of g. And when we say f of g, that means we're going to plug g into the function f. And the other way we write this, I call this fog, by the way. This is f of g. And it looks like f of g of x. Just as I was to say f of 3 means to take the 3 and plug it in place of x, This, I'm going to take the whole function g of x, and place it in place of x. So let's go ahead and try a couple here, just as we like to do. Let's say our function f of x is equal to x squared plus 1. And g of x is equal to, let's just say it's x plus 1. And I wanted to find what was f of g of x, or the FOG, whatever one you want to use here. Well, this tells me to take the g of x function and plug it in place of all of the x values in f of x. So I'm going to take the f of x function is something squared plus 1. So that something is now x plus 1 squared, and then plus 1. So it's something squared plus 1. And here I have to FOIL x plus 1, so I get x squared plus 2x plus 1 and plus 1. So this parentheses thing here, this FOILed, becomes x squared plus 2x plus 1. And I get to add 1, so I get to combine like terms. So I say it's x squared plus 2x plus 2. All right, so that's f of g of x. I could also do the other way. I could say, what is g of f of x? Well, this says take g of x, or sorry, just take f of x and plug it in place of all of the x's on g. So I'm going to take that, I'm going to plug in x squared plus 1, and I'm going to add 1 on the back. So this just becomes x squared plus 2. All right, not so bad. What if I was to say this f of x is equal to x squared plus 3x minus 7, and g of x is equal to 2x minus 6? Well, let's just see what f of x does. Or sorry, f of g of x is going to happen. So f of g of x says take the entire g of x function and plug it in place for all of the x's. I'm going to do a little bit middle thing here. No, let's go ahead. G of x is 2x minus 6. So I need to square that. So I need to say it's 2x minus 6 squared. And then I'm going to plus 3 times 2x minus 6. And I'm going to subtract 7. Right, so this was x squared plus 3x minus 7. Now, x's are represented by 2x minus 6. If I was to FOIL this, I would get 4x squared minus 24x plus 36. Distribute the second piece becomes, 6x minus 18 minus 7, and all I have to do is combine like terms now, and I get 4x squared minus 24 and plus 6 becomes a minus 18x. I get a 36 minus what ends up being 25 becomes plus 11. And there we go. We have our f of g of x. Now, you might remember a problem that we had a little while ago that looked a little bit like this. Let's say it was x squared plus 2x minus 1, and I said that g of x was x plus h, and I wanted to do f of g of x. And it would look a little something like this. I would take the x plus h and plug it in for x in f. So this becomes x plus h squared plus 2 times x plus h minus 1. And we can go ahead and FOIL all of this and do some combining of any like terms we might have. There's not going to be many here. Actually, I don't think there's going to be any at all. If I FOILed x plus h, right, this is x plus h times x plus h. So I get x squared plus 2xh plus h squared. Distribute here, I get 2x plus 2h minus 1. And there's nothing we can actually do here because of the way the things line up. But that is the composition of x plus h into f of x. All right, composition just takes a little bit of practice. You need to practice this skill in order to get better at it. One of the other things that we can do is to do some of this stuff graphically. Let's say you were given a graph of f of x and g of x, and you wanted to write the sum of f of x and g of x. Well, that's basically along the same lines of our graphical transformations that we were doing. And if I was to give you the point 2, 0, 4, 2, and 6, 1, let's call that line f of x. And let's change our pen color for g of x here. Okay, so the point 2, 4, the point 4, 0, and the point 6, negative 2. And that is the line for g of x. And if I wanted to write what was f of x plus g of x, that really just ends up being adding the adding the y values. So in this particular case, the y value here is 0, the y value here is 4, and if I added those two things together, that would be 4. So I get a new point of 4. Here I get a new point of 0 plus 2, so it's 2. And if I add these 2 points together, the y values is negative 2 and 1, so I get a y value of negative 1. And this new line is f plus g of x. All right, so adding functions on a graph are not really hard. All we have to do is add the y values given any y values that we have. All right, I think that's going to, that's going to finish us off here today. Hope you guys learned a little bit of stuff, and I will see you guys tomorrow.